How many broadcast and collision domains on this local area network? Here, as you can see, we have 2 routers, 2 switches, and there are some hubs connected to these routers and switches. So, what do you think? How many broadcast and collision domains on this topology? Let's firstly count the broadcast domains. Each router interface is one broadcast domain. The below router has 3 interfaces. 2 of them is connected to hub and 1 of them is connected to the other router. So here we have 3 broadcast domains. The other router is connected to the first router and the other 2 switches. So the other 2 interfaces are also broadcast domains. We have 3 plus 2, we have 5 broadcast domains. How about collision domains? Each router interface and switch interface is one collision domain. Here we will count all the interface because we have routers and switches. So we will count the router interfaces and switch interfaces as collision domains. When we count these interfaces, we have 7 collision domains. Our answer is 5 broadcast domains and 7 collision domains. What is the next hop for this static route? Here I am asking the next hop that we need for a static route. Here's the topology, and on router 1 we will write a static route. So to reach 172.16.0.0/16 network, which next hop should be used on router 1? What do you think? Let's remember how we write static routes. So to write a static route, firstly we write the destination network and destination subnet mask, and then we write the next hop to reach that destination network. So here from router 1 the next hop is 10.10.10.2 because it is the next hop to reach this destination network. In this static route, we should use 10.10.10.2 as next hop. Here's a ping problem question, and PCA cannot ping PCB. So, what can be the reason? Let's check each choice one by one. Incorrect subnet mask on PCB, incorrect default gateway on PCB, incorrect subnet mask on PCA, incorrect default gateway on PCA, and incorrect IP address on PCA. What do you think? Here let's go one by one. Incorrect subnet mask on PCB. PCB subnet mask is okay, 255.255.255.0, and incorrect default gateway on PCB. So the PCB's default gateway is the interface of router 2's interface IP address, so it is also correct. Incorrect subnet mask on PCA. Yes, here the PCA subnet mask should be 255.255.255.0. So our answer is here, C. And let's also go through the other answers. Incorrect default gateway on PCA. No, the default gateway of PCA is the interface of this router interface, so it is okay. Incorrect IP address on PCA. No, IP address of this PCA is also in the same network with its gateway, so it's also okay. For this question, our answer is C. Incorrect subnet mask on PCA. According to this EIGRP configuration, which 3 IP addresses will be received by other EIGRP routers? So, let's see the answers one by one. 10.0.0.0, 172.0.0.0, 172.16.0.0, 192.168.0.0, 192.168.1.0. What do you think? You will select 3 of these IP addresses. According to this EIGRP configuration, these 3 IP addresses will be received by other EIGRP routers. These are 10.0.0.0, 172.16.0.0, 192.168.1.0. So for this question, our answers are A, C, and E. Which user password is configured with these configuration commands? Here is some configuration commands, and these are line YTU 0 and 15, password ABC123, and login. Which user password is configured here? So what are the choices? SSH, Telnet, Auxiliary, Console, and none of them. What do you think? What is the correct answer? And here the correct answer is Telnet. Which one is the correct match? Let's read them. Physical, data link, network, transfer, and session. And we have also some options here: bits, packet, data stream, frame, and segments. Which one is the correct match? Physical layer is related with bits, data link layer is related with frames, and network layer is related with packets, transport layer is related with segments, and session layer is related with data streams. So for this question, our answer is C. Which one is related with TCP, Transmission Control Protocol? Let's go to choices one by one. Sends transmission in sequence, transmits packets individually, transmission includes an 8-byte header, uses a lower transmission rate to ensure reliability, transmits packets as stream, higher transmission rate for latency sensitive applications. What do you think? Which ones are related with TCP? Let's go to choices one by one. Sends transmission in sequence. Yes, this is the property of TCP, Transmission Control Protocol. Transmission packets individually. No, this is not true for TCP. Transmission includes an 8-byte header. Yes, no, this is not the property of TCP. This is the property of UDP. So 8-byte header is UDP header. Uses a lower transmission rate to ensure reliability. Yes, this is true for TCP. Transmit packet as stream. Yes, also this is true for TCP. Higher transmission rate for latency sensitive applications. No, this is the property of UDP. So our answer is 1, 4, 5. Another ping problem here, and here PCA cannot ping PCB. What can be the reason? Let's go through choices one by one and find the correct answer. Incorrect subnet mask on PCB. Here let's check the subnet mask of PCB. It is 255.255.255.0 and it is correct. Incorrect default gateway on PCB, and default gateway of PCB is also using the interface IP address of router 2. It is correct. And incorrect subnet mask on PCA. Now PCA subnet mask is also correct here. /24 subnet mask. And incorrect default gateway on PCA. The default gateway of PCA is also correct. The interface IP address of this router 1. And how about E? Incorrect IP address on PCA. Let's check the IP address of PCA. 192.168.0.5. Yes, we found it. It must be 1, not 0. When we use 0 here, it is not in the same network with the default gateway. So we should use 192.168.1.5 as IP address. Here's a drag and drop question about control plane and data plane. Here we have 6 choices and you will drag and drop these 6 choices under control plane and data plane. So let's read the choices. Quality of service, filtering, routing state exchange, established telnet session, data encapsulation, device access. What do you think? Which ones are related with control plane and which ones are related with data plane? These choices are related with control plane, routing state exchange, established telnet session, device access. And data plane related things are quality of service, filtering, and data encapsulation. How many broadcast and collision domains on this local area network? Here we have a local area network and we have 2 routers and 4 switches. Let's firstly count broadcast domains. Each router interface and each switch itself is 1 broadcast domain. So here we will count the interfaces of routers, so it will cover all the topology. For this example, we have 5 broadcast domains. How about collision domains? This is also a tricky question, so here the collision domains are also same with the broadcast domain, because each switch interface and each router interface is 1 collision domain, and here to find the collision domain number, we need to count all the switch interfaces and router interfaces, and the number of collision domain for this question is 5. Our answer is 5 broadcast domains and 5 collision domains.